Can you guys hear me? Good? All right. Good morning. Today we'll be talking about Buildtest, which is a HPC software stack testing framework. Just by show of hands, for any of you, if this is the first time, can you just raise your hand? Okay. All right. Thank you. All right. So just starting, we'll just talk about the motivation about how this started. So what we want to do is actually want to do testing of installed software in HPC software stack. So that's the goal. And some of the requirements are, well, we need a framework that can automate the testing process. So, we have tools like EasyBuild and Spec that do the building of the software, but we're focusing in this talk on testing, right? So one of the things that we want to be able to do is, because software stack is integrated with module system, the framework has to be integrated well enough to talk to the module system to be able to test the specific software that we install, right? The framework has to be able to provide some kind of like a markup language so that users can actually write the test. In this case, something like test configurations, which I'll talk about. The framework has to be able to automate the test creation and the execution. So, back in the day, most of us probably just write our homegrown scripts. Well, the idea is to use a framework to automate this, but have like a uniform language so that everyone can be able to use the same syntax. And the framework has to be able to provide a test repository, right? That is community driven. That's the whole point. That way we can all, at some point, be able to share the test and port it to our own sites. Buildtest is not meant to replace tools like Make, CMake, AutoConf. Their purpose is different. They're build tools, even though they do testing, but Buildtest is targeting HPC software stacks. So what is Buildtest? Buildtest is a framework that automates test script creation. It abstracts the test complexity by using YAML as this markup language. The tests are portable, meaning if you have multi-clusters, you write a test, you can reuse that test with some minor modifications to work on the other site. But most of it will work. And it provides many of the module operation. I'll cover some of this in this talk. And you can see the documentation is on Read the Docs, so you can access it there. And it comes with a repository of tests when you clone Buildtest. So Buildtest, this is a pipeline of how you start out. You as a user will pass in a configuration file, which would be written in YAML, into the framework. The framework will load the YAML, and then it will kind of check the schema, the key value pair, making sure the syntax is correct. And if it does fail, it will warn you or exit immediately. And then you have to fix it, go back and then fix. And then if it passes, then it will kind of do a detection of the programming language, because that's the first thing it's required to then detect the compiler, MPI, and based on that, it can actually build a command line, like to actually compile the source code, which is this step. And then it will generate the actual content of the test, which are just kind of other things like compiling, loading the modules, and then running the execution, cleaning up. In this stage, the module load is actually done after the test script creation, so there's several ways modules can be loaded in, like active modules, so whatever you have in, it will just be loaded in. LMOD user collection, the module collection, which is an implementation of Buildtest's own module collection system, and then module permutations and other. And then finally, it will just write the script, and then you can execute it. So to build a test, the command is called buildtest build, and then -c is for configuration, and then the test configuration. The configuration files are in the toolkit suite directory in the root. This is kind of a view of kind of the directory structure at the point. Just to give you an idea of how the tests are written. So you have something like, for instance, like a directory called tutorial compilers, and then you have like some YAML file, rx.c.yaml. The name of it is just replacing the file separator with a dot at the moment, so you can actually get this. So this command is what you would pass in to over here. And then you need to have a source directory where you put in all your source code, and then all the YAML files have to have the .yaml extension. Otherwise, Buildtest will not find it. This is an example of a test configuration. So the first 2 lines is just kind of just explaining a little bit about the test. Description. This is a field that says just information about what this test does, so any user can write anything they want. This test will run, in this case, the scheduler key just tells, okay, do you want to run this locally or with a scheduler? Buildtest has features to run it with a scheduler. And then the program section is where you start the declaration of the test. So you can specify compiler. In this case, you specify the name of the compiler, in this case, GNU, Intel. You don't specify the actual compiler like wrapper, like GCC, G4tran, whatever, because Buildtest will get that for you. You can specify the source file, right? That's relative to the source directory. You can declare your environment variables, in this case, like foo equals bar, x equals 1, whatever. You can pass in shell commands before you build, so pre-build and post-build, before and after the build, meaning the compilation. You can pass in flags to the compiler, in this case, C compiler, and then also run commands before and after, which are also shell commands, before and after the execution. And you can pass in the arguments to the executable. In this case, I'm passing in hello world. So that's basically kind of an overview of this configuration. Talk about the language compiler and PI detection. The first thing is, based on the source file extension, it can detect the language based on this. From there, based on the language and the compiler key, Buildtest will figure out which compiler to use. MPI, the same thing with the MPI flavor. So that's kind of just giving you an idea of how things are going. It's part of the documentation, and it's growing. So here's an example of Intel. So we're doing a hello world in Intel. So we say compiler is equal Intel, and then we build the test. So in this one, I'm showing an example where we're passing in an LMOD user collection called Intel -COs for collection name, and it will find it automatically, a pre-populated list based on the collections you have, and it will inject that into your module, into your test script. So you have module restore, etc. You can notice that the compiler, when it's set, it will set the FC to I4 because it's a Fortran program. The F flags get set right here, and then this is your compilation command right here, FC, FF flags, etc. This is actually run with a dry mode, which is a feature in Buildtest that says just print out the test content without actually generating the test. If you get rid of dry, then it will actually generate it. Right. Here's an example of PGI, and this is basically a vector addition program in OpenACC, and it requires linking with math library. So to do OpenACC acceleration, we set C flags equal -ACC, compiler is PGI, and then LD flags to specify, linking with the math library, and then all of that gets set up right here, CC, C flags, LD flags, and then this is the compilation line. And then, it executes and then cleans up. We have another example with Clang. We also recently added this support. So we're doing an OpenMP example here where we're running with 2 threads. So we have to also specify -fopen in C flags. And pre-exec, what it does is actually, in this case, it puts the command before the executable. But certainly, you can also set it as an environment variable. and that's just one way of doing it. Every build that you do in Buildtest will be tracked in a JSON file, build.json, and you can do a Buildtest build report, and it will just kind of show you a table format of all the builds, ID number, build time, and then number of tests that were generated, and then the actual command. And this ID number can be used to actually like retrieve the logs, the run, and to actually run the test. So one of the things that you could do is you can run the test locally. In this case, we could do build test build run and then the ID number, and it will run all the tests within that suite. Every build will have a .run file which contains the output of all the tests, and then a 0 exit status will be passed and non-zero is failed, and you will see it. The number of tests that were passed and failed, it'll show you in the output. And then you'll have like this long line here, which is the run file, which you can view for the output of the test. So Buildtest has a very, it's tightly coupled to Spider because it solves a module load problem inside the test. The command specifically that Buildtest uses is a Spider -O is the output format, and Spider JSON is one of the types of output format that you can have, and then basically all the trees that you pass in. You can specify one tree, you can specify multiple trees, but in Buildtest it's just called Buildtest module path, which contains all the trees. And Buildtest will then leverage the Spider to actually load the JSON because it actually parses the JSON file, and then one of the nice things is that Spider is automatically updated when module path change. If you have the Spider, if you update the Spider cache, everything will be up to date, and Buildtest can actually use up to date modules. But it also fixes the hierarchical module problem. We have to load compiler, MPI, and stuff, because since we parse it, everything works. And it also works even if you have like SPAC and you rebuild all the SPAC modules with different hash code, everything will work. Just to give you an idea of what it looks like, there's maybe a little hard to see, but the keys that are important are the top level key, which is the unique software, and then the inner level key is the actual file path to the module file. So you may have, like, let's just say in this example, this is Anaconda, you have multiple versions. So you'll still have Anaconda, in this case Anaconda 3, and you'll have a key that's the file path, and then inside it will be all the metadata into the module file, like the full name, version, URL, etc. The one that we care about is the full name. That's the way to actually load the module. And if you decide to change it, Spider will pick this up. So that's what Buildtest used to actually parse it and then figure out how to load modules. This is a snapshot, I think, of LMOD 6. I'm not sure which one, but LMOD 6 and 7 have difference in this JSON file, and there could be changes going down the road. So. But the ones that are more important are these keys, the full name, and then the actual module file. So one of the things that we could do is we could do a listing of all the modules. You parse the Spider record and print the full canonical name. So this is the first table, is the actual way to load the module. So you can see this, basically similar to like module AV, but with other metadata, like for instance, the actual module file path. This is actually more than just doing a module AV. What it does is it's actually retrieving all the modules from all the trees in Buildtest module path. And you'll see kind of like some additional features that I've implemented where you can actually do some, let's say, filtering by modules. You can exclude module versions, version files. So I think with the help of Robert, he was able to help me figure out some of these things. So like you want to exclude .version, .modulerc, .modulerc Lua because they're part of Spider record. So I fixed that. You can also do query limit. If you set it to -1, it will print everything. If you set it to a non-zero value, it will print up to that limit of entries in here. And then the include is like filtering modules by the full canonical name. So here's an example. I want to search, like, for instance, GCC, Python, and zlib, right? You can do this in the configuration, which is settings.yaml file, or you can do it through the command line and pass in each of them. In this case, it's only the name, not the version. And then what it does is actually prints all of the modules out. So this is a pretty nice way for users or sysadmins to do like documentation if they want, or users to find stuff. This is just talking a little bit about the configuration file. Buildtest will store the configuration in your home directory. It's a file called settings.yaml. If it's automatically like if you delete it or if it's not found, Buildtest will automatically put it in if you run Buildtest. You can view or config or edit the file, like Buildtest config view will just show you the content of the file, or edit, which will just open up an editor, or you could do it manually. And if you're interested in configuring this, you can go to this URL. The ones that are kind of important are Buildtest module path, Buildtest spider view, which I'll cover, and then some of this module stuff. Right now we covered module, this section right here, and we'll cover some of the other ones. Here is just a kind of view of the report of the Buildtest configuration. You could do Buildtest show -- config, and it'll just give you like all the configuration values that are set, and that could be useful to troubleshoot or when you're using Buildtest. So I have an account at Stampede, so I think this would be like typical use case for even any other sites, maybe like a user who wants to find modules built with a certain compiler. Stampede, they use hierarchical modules. So let's say a user wants to find all Intel modules, Intel 18. So the first thing you could do, user comes and sets a module tree in Buildtest. So Buildtest module tree -s is for set, and then the name of the tree. And then it will update the module tree into your configuration. And then you can do Buildtest module tree -l, which is for list, and it'll show you all the active module tree roots. Think of that as like a tree in module path. You don't have to change module path, but you just change it in Buildtest. Then you can do Buildtest module list. What I showed previously, it will show you basically the content, what you see in module AV, but in tabular format, you see 30 modules, and that's what you will see if you're in Stampede. Now, we saw 30 modules, but in fact, there are more than just 30 modules, because with Intel, there are stuff compiled with Intel and PI and other stuff, so there's other subtrees. In total, there was about 320 modules built with Intel. There is a command called Buildtest spider view. You can change it in the configuration, or you could set it in the command line, and you can say -all, Buildtest spider view equals all, and it will show you kind of like a really long table. At the end, you see 320 modules. All the stuff that you see in green are Lua modules. Stuff that you see in white are non-Lua, so it kind of helps to also troubleshoot that. So it's just a way of how Buildtest represents the data. Buildtest can also automate the module load feature, module load testing, which is pretty cool. So imagine you have like thousands of modules. Buildtest can do it with one command. So in version 0.75, there were some other features I added. So one thing that was discussed was like, I think I asked this with Robert also. Well, one, we would like to do testing in login shell. So by default, it's set to false, which means it will run in subshell. But if you set it to true, you can run in a login shell, each module load test. Num test is the number of tests you want to do, and purge modules is purging the modules before you run the test. You can set it to true, which will purge it. You can set it to false, and then it will not purge it. So here's an example. On the command line, if you just say Buildtest module load test, it will just run all the tests, all the modules in that module tree. And it could be many, and it could take a long time. So num test 5, it will just stop after 5. And this is the command that was run, module purge and then module load. And it will show you the actual module file that's being tested, and then afterwards it'll show you number of passed modules, number of failed modules, and it will tell you, it will just write out the results in a file. You can do same thing, but in a login shell. It does take some time. It really depends on your system how quickly it can load, but it will do it'll just run up a login shell and then do module purge, and then it'll load the test. Load the module, and then it's pretty simple because when you run module load, it will say it will pass or fail, right? And we're just checking the exit status. That's how Buildtest does the testing. Now, the testing may result in some false positive, and it's really up to you if you think it is. Anyhow, Buildtest can also report modules like for EasyBuild and SPAC. It's pretty easy to do because EasyBuild and SPAC both have a signature in the module file, and Buildtest just reads the module file and checks if that signature is there, and it just reports all the modules listed. I particularly use both EasyBuild and SPAC in our environment, so to differentiate the two is kind of important. Users can also retrieve like all the parent modules. So parent modules are modules that set module path. Hierarchical module, that's pretty true, but you could set any module path in a module file. There is a command called Buildtest module listing all parents, and this is really cool because as on a site, you can just run this one command and you can get everything. You can get all the modules and then the actual file path. And this is a quick way of finding out where all the modules are that actually load. And you can notice that most of it are compilers. We have GCC, IMPI, Intel. The next thing that users can do is take one of these parent modules and then do a build test module, and then -D, and then take the parent module, and what it does is it prints out all the child modules. Meaning when you load that module, you should see the other tree that comes up, which have all the other modules. And this is a way of finding out where stuff is in your subtrees. And in EasyBuild, it would also work the same way. And this is just showing you with GCC 5.4, we have 2 modules, so IMPI, not MKL, and then GCC 6, we have 4 modules right here. It's just showing you the full path to the module, and that way you can troubleshoot. Buildtest also added support for Travis in 0.7.4 and then 0.7.5. It added some more improvements. Currently, there's about 30 regression tests, and it's growing. Some of the tests require to do some testing on the module side, so we kind of install like a mini EasyBuild stack inside of Travis build. Just a couple software just to do that. And we're testing Buildtest with Python 3.6, 3.7, 3.8, and LMOD 6 and 7 for the time being. And we'll soon add LMOD 8 in there. And we also introduced coverage report, code coverage, and coveralls. So we also have, this is code cov right here. We also have code cov bot that does the integration. So on a pull request, it can get you the report. And coveralls is something recently I added in, which is more in-depth coverage report. I like the tools. It integrates pretty well with Travis. And you can get the builds. You can navigate from here and get the Travis build and then go back. So funny thing is that some of the output of coverage reports is a little bit different, just by 1% or so between this and code cov. So that's still something I don't know why it is, but it is. Some of the issues that we have, so from the Travis point of view, since we have a limitation on build time, I can't just take forever to build like a large stack and test everything. So for some of the regression tests, I still have to figure out how we're going to do this. So at the moment, we're just building 2 or 3 software packages and then test the module feature, like the module load test and other features, because we need to have a module stack in order to do this. And then one of the things that I was thinking about was, well, we could try to build the EasyBuild container in Singularity, pull the images in Travis, and then rewrite some of the regression tests. So that way to reduce some time. And this is kind of the EasyBuild workflow, which I think I talked about yesterday. But it's pretty, straightforward. First, you use EB to generate the recipe file. You specify easy config, -seed, experimental are both required at the moment, and then the container config. And then you specify the bootstrap. Once you have the recipe, then you have to log into, in this case, if you're building it remotely, on Scilab, Singularity remote login, and then do the Singularity build, --remote, and then the image, and then the actual recipe. All of this stuff is, if you want to sign the key, you want to generate the key, and then, sign the container. This is optional. Though it is recommended by Scilabs, and you can push it, you can also push unsigned containers, but if you want to do it, you have to do all of these steps for step 4 and step 5. So I want to just talk about some of the GitHub integrations. This may be helpful for some of the other open source tools that we have today. So we talked about Travis, coveralls, CodeCov. We also have CodeFactor. For security, we have SNCs and guardrails. We also have some bot integration, issue label bot and stale. These are for managing issues in GitHub. Issue label bot just does labeling using machine learning. And it labels the issue. Stale just closes the issue if there's no activity after X number of days, and you can configure this. Trafico and pull request size are for pull request. Trafico is pretty interesting. It's kind of like a workflow management around pull requests. So you push, and then somebody else reviews. It just changes the label, and then you can close and merge. Like once you merge the pull request, it can update all of these labels, and it could be pretty cool for the maintainers to actually use. Pull request size is like for if you have a commit diff with like X number of lines, it can label it based on the size. And we also have, like, for instance, GitHub Actions. So Black Code Formatter is for, it's a pretty cool tool. I'll show you that. And URL Checker, which is for checking URLs. So what Black Code Formatter does, it basically just auto formats all your Python code in just one, with just one, let's just say, syntax. There isn't any decision, like it's all compliant with PEP 8, but it works out of the box, and it's really simple. It's probably hard to see, but over here it's just saying it's reformatting all my Python code, and it updates it, in this case, on both push and pull requests. Just show you the other one. The URL checker is another one. It's pretty cool. I would recommend it for any of you guys that use, like, if you have documentation or stuff that broken links. URL checker, what it does, it just kind of goes through all of your source files, and it checks. If you see a green, that means good. If you see an X, that means bad. It'll complain to you, and then you can go through every single one and then see how it works. So I found this to be pretty useful. There were like a couple of them that like in my changelog that were broken, so I have to like fix those. But you can use this. It's pretty cool. It's in the marketplace, and that's pretty much it. I think to wrap up, some of the things that I want to that I thought about. The current YAML schema has some limitations. They don't address some of the things, like, for instance, I could do at the moment, like declaring variables in the test, right? Just shell variables, or doing permutations, right? Like if you have to do permutations across compiler flags, you want to do multiple runs, permute that with environment variables or compilers. Like you want to test one with multiple compilers. Or if you want to do like a range of values for a test, like you build it once and you test it with like multiple, like let's say a range of OpenMP threads, right? Or like doing multiple source compilations. Right now, the building and the execution is separated out. I'm thinking about doing merging the two together, so it's just one operation. And obviously, in the big, there's a lot of work needed to be done on the on the regression test. So that's something that I need to focus on. And that's pretty much it. And then we have the references for if you guys are interested. Thank you.
There is a question from the chat specs, from the channel. Can you use configure make for building?
Configure make, is that the question?
Yeah. Can you use configure make for building in the?
Yes, you can. At the moment, you can. It's certainly possible, but I don't think the schema is set up to use the right keys. Meaning, I should have like just a section where you could just say script, like, and then they could just write their whole script in there. Something similar to like, in Travis where you have like script or install and then to just put in. But yeah, certainly you can.
Couldn't you use the pre-build command and do the configure
that is
there?
Technically right. You can use that, but it's not like the key may be a little bit misleading. They could certainly do it there, but yeah, I would want to have to change some of the structure around to make it clear.
So you did a lot of module purge on the examples. Is it like intentional, or Buildtest adds the module purge?
Yeah, that is a feature that is added in, but there is a configuration. I can certainly talk about this, and maybe I can even add this in, but there is a feature. Well, this is for force purge. So if you set it to false, it won't force purge, but I can potentially have something like Buildtest module purge and then set that to false, and then they can purge. This is just more of technicality. In some systems, you may want to not do force purge because you may screw up your environment, because some sticky modules are important. Like I know, I used to have a Bright Cluster Manager, and they have like lots of modules that are preloaded, and if you do a purge there, it's not good. But,
Does it make sense that you actually have a feature to look at the conflicts? You try to load a module, show the module first, look at what the conflicts, and see if conflicts are loaded, and you load only those conflicts. So you don't do purge, but you just unload whatever it's gonna be conflicting before loading the module.
Yeah, so we don't. So the thing is, we don't have to worry about conflicts. Everything that is taken care of is through this spider command. So the full name is actually used to load the module name. If there is so the conflict part is, so I'm not talking about the conflict, but there's another key called parent and parent AA. Those are for modules that you need to load first before you can load the other module. That's only for hierarchical modules. And I actually parse this spider record to actually get those to load the modules properly. Now there's multiple ways to load modules. One of them is just active modules. So before you build the test, if you have modules loaded in and you don't specify anything, it will just load everything that's in the active modules. If you have lmod user collection, you say like you have some module XYZ, you do a save, then you can reference that, and that's what this example was. I have an Intel module collection. So that's another way of doing it. So, we're just completely relying on some of the lmod tools, and Buildtest has its own kind of module collection system, which I didn't cover, but if you're interested, I have that in a previous talk in supercomputing that I talked about this. So in terms of the conflicts, if there is a conflict, Spider should know about it. That should solve the issue.
Anybody else? Nothing? Thanks very much.